Good afternoon, class. We are looking at practice test number 4, covering chapters 8 and 9. Here's chapter 9, systems of linear and nonlinear equations. Reminding you of, if the system of linear equations results in two parallel lines, the system is inconsistent. If the system of linear equation results in two intersecting lines, the system is a consistent system with a unique solution. And if the system of linear equation results in a single line, the system is dependent. So the first case, inconsistent system. So two parallel lines, inconsistent system. The system has no solution. The graphs are parallel lines and they have the same slope with different y-intercepts. If you solve, you end up with the following contradiction, such as 0 equals 7. Equal slopes, different y-intercepts. The second case, when we have two intersecting lines, now you have a consistent system with independent equations. The system has a single solution at the point of intersection. The graphs are different. They have different slopes. So if you were to solve for y, you find they have different slopes. The last case, a single line. It's a consistent system with dependent equation. The system has an infinite number of solutions. The graphs are identical. They have the same slope and y-intercept. So if you were to solve for y, they become identical. They have equal slopes and equal y-intercepts. If you were to solve them by substitution or elimination, you get something like 0 equals 0, which is an identity. All right, we want to solve these systems. If they don't ask you by what method, you can use any method. And of course, this one we notice if we multiply this one by 5, we can easily use the elimination method. So multiply the first one by 5. The second one, don't change it. You get minus 5x plus 10y equals minus 5. If you add them up, these two cancel each other, these two cancel each other, but these two don't. So 0 equals 1 is a false statement. That means no solutions. That means the two must be parallel lines. It's an inconsistent system. The two lines must be parallel lines. What about this one? If you decide to get rid of the y, you can multiply this one by 3, this one by 7. If you want to get rid of the x, you can multiply this one by 5, this one by 2. So let's get rid of the y. If you multiply by 3, you get 6x minus 21y equals 9. That's the first one. The second one is negative 35x plus 21y, 7 times 7, 49. Now, if you add them up, these two cancel out. This will give us negative 29x, 58. Divide by negative 29. X becomes negative 2. You put that into one of the original equations. For example, the first equation. 2 times x, which is negative 2, minus 7 times y equals 3. So this is negative 4, moves, becomes positive, and y becomes negative 1. And you really have to check. So just to check, I'm going to check one of them quickly. And that means the second equation, because equation number 1 was used, right? I don't have to check it anymore. So minus 5 times x, which is negative 2, plus 3 times y, which is negative 1, equals 7 We are checking. That's why I have a question mark here. 10 minus 3 equals 7. And it checks. So it literally takes you seconds to check, and it's extremely important to do so. Matrices represent a rectangular area or table of numbers. A matrix with m rows and n columns has dimensions m by n. M rows and columns. A square matrix has the same number of rows and columns. The dimension would be n by n. We can add matrices with the same dimension only. That means the corresponding elements must be added. For example, this one must be added with this one, and we get 1. This one must be added with this one, and we get 0. 8 must be added to 8, we get 16. 9 must be added to -3, we get 6. So corresponding elements. What about the product? The product of AB of an m by n matrix A and n by k matrix B is an m by k. So you can only multiply them if they have the following situation. The number of columns of the first and the number of rows of the second are the same, and the result will have the size rows from the first, columns from the last. Therefore, it's m by k. So how do we multiply? First of all, this one is 2 by 3. This is 3 by 2. And the result is therefore 2 by 2. So that's the first thing. Okay. So the way you multiply these two and add them up. See, -3 times -6. Let me write it up here so you see what I mean. So -3 times -6 plus 4 times 2 plus 2 times 3. So you have 18 and 8 and 6, 32. So that means the result will have number 32 as the first integer. Then you multiply it by the second in the following manner. -3 times 4 plus 4 times 3 plus 2 times -2, you get -4. That means this one is negative. And then you multiply this one by this one, you multiply this one by this one in the same manner, and you get the following. So I did the first row. You can try the second one to make sure you have it right. It's very straightforward, everybody. Let me clean up my mess. So matrix methods to solve systems of linear equations. REF, row echelon form or method. Apply row transformations to get ones along the diagonal. A leading coefficient is 1 and zeros below the augmented matrix. Or REF, reduced row echelon form. Apply row transformation to get ones along the diagonals and zeros both below and above the augmented matrix. Every leading one is to the right of the one above it, and any non-zero rows are always above rows with all zeros. So this is the concept known as row echelon form versus the reduced row echelon form. So we want to go back to question number 2, and we are going to use matrices on them just for the sake of practice. So we want the augmented matrix. So minus 1, 5, 2, negative 10, negative 1, 6. This is the coefficient matrix. This is the constant matrix, the right side, and this acts like an equality sign. So we want to solve this system. We want the first entry to be 1. All you have to do, multiply the first row by negative 1. So minus R1 gets to R1. That means this becomes positive 1, negative 2, positive 1. And you're not changing the second row. The next item, when you get 1 here, everything underneath, it doesn't matter how many rows, all of them, you have to make them 0, 1 by 1. And of course, there's only 1 row, so let's make 5. One easy way is to multiply the first one by 5 and subtract it from this. So minus 5 R1 plus R2 will give us 0 here. Minus 5 times 1 plus 5 is 0. Minus 5 times negative 2 is positive 10, and negative 10 gives us 0. Minus 5 times 1, minus 5 and 6 adds up to positive 1. So what happens is that the last row is 0, 0, 1. So the final row indicates that the system is inconsistent and has solution set pi or an empty set. There is no solution, everybody. We can use matrix editor. It's been explained to you before. So matrix editor found by pressing second x to the power minus 1. Use the arrow key to the right to edit dimensions and press enter, put all the entries. So, and how to solve a system, you go with row echelon form, go to the math part of it, and matrix editor found by pressing second x to the power minus 1, then math or EF or row echelon form will do the job. So matrix, first you change this to a desired dimension. This has 1 and 2 rows, 1, 2, 3. This is a 2 by 2, therefore, system of equations, therefore it becomes 2 by 3 because of the last column. And so you enter this augmented matrix in there. If you do REF, you see the answer right here indicates what we just came up with. Okay. We are going to write the augmented matrix, which means a 2 minus 5 minus 7, 3, 3, 7. You can line them up, or you can go with the row 2 minus 7, 3 minus 5, 3, 7. And for the equality, you have a line segment. This acts as a equality. The very first thing is to make this guy 1. Okay. So one way is to multiply this by 1/2. If you want to avoid fractions, you can multiply this by 3, you get 6. Add to this one, you get 1. So 3R1 plus R2. This is because sometimes fractions can create problem when you want to add them up. So when you do that, you get what you want here, which is 1. What happens down here, you're not changing anything. So 3 times 2. So this one repeats. This one is 3 times 2 and minus 5 is 1. So 3 times minus 7 is negative 21. With 3 adds up to negative 18. 3 times 3 is 9. With 7 adds up to 16. So the second row remains. The first row changes accordingly. Now for the next one, we're not going to change the first one. We're going to keep it intact, but we want to change this one to 0. We want this one to go to 0. So we can say 5 of this row added to this row. So 5 row 1 plus row 2. And that would be the new row 2. If I multiply this one by 5, I get 5 and negative 5 is 0. If I multiply this one by 5 times negative 18, I get negative 90 and 3, I get negative 87. If I multiply this by 5, I get 80 plus 7, I get 87. So these are what I get as my new matrix. It's easy to get rid of this and make it 1, divide by itself. So negative 1 over 87 times this row. So the first row doesn't change. This becomes 0 because 0 divided by this number is the same. This becomes 1. This becomes negative 1. And right away, this pretty much gives you the answer as follows. Let's write now the system corresponding to this. The system corresponding to this is x minus 18y equals 16, 0x plus 1y is negative 1. This indicates y equals negative 1, of course. Now you put it here, you say x minus 18 times negative 1 is 16. So x plus 18 is 16. Subtract it, and you get x equals negative 2. If you go through the matrices, everybody, and the technology, so the answer is negative 2, negative 1. Let me just write that here. And of course, I'm going to leave it for you to check. And checking only takes place with the original system, nothing in between. So those are that's the solution set. Let me erase my board. And so now you have the matrix with the dimension, and you enter the augmented matrix. Going to go with REF gives you this number. If you go RREF, it gives you the actual answer. This is the identity matrix, and this is the solution. Very straightforward. Use Cramer's rule to solve this system, and this is another method. Again, we are looking at the same question, various methodology. And so I'm going to remind you of the determinant. The determinant of a 2 by 2 matrix is the cross product. So when you have it in this format, this is the notation, looks like an absolute value. That represents the determinant, AD minus BC. And Cramer's rule for two equations containing two variables is that if you have ax plus by equals s, cx plus dy equals t, therefore, first, understanding the D matrix. The D matrix is the coefficient matrix, but its determinant, A, C, B, D. Take a look at this one. This denominator is the determinant of the coefficient matrix. Okay. And what happens is, this is the determinant of the coefficient matrix. which is AD minus BC. Note that we replace the first column of a D by the solution matrix D sub X. That means S and T. And we replace the second column of D by the solution for D sub Y. So if you look at this one, the first two have been changed. In this case, the last two have been changed. So that's good to know, okay, how we arrive at each case. All right. So let's start with the D matrix, so the coefficient matrix. And if D equals 0 and at least one of the determinants, D sub X or D sub Y or D sub Z, if we happen to have a 3 by 3, is different from 0, then the system is inconsistent, has no solution. If D is 0 and all of the determinants are equal to 0, then the system is consistent and dependent. So there are infinitely many solutions. So again, if only D is 0, we have an inconsistent system. If all of them are 0, then we have a dependent system. That's the bottom line. So starting with this, we're going to put 2 minus 5 minus 7, 3, and their cross product is the determinant 2 times 3 minus negative 5 times negative 7, and that's 6 minus 35 or negative 29. Now, we are going to replace these with this to get D sub X. And now do the cross product. There's a typo. 3 times 3 times 7 minus 7. 9, 49. They add up to 58. Notice in this case, we are replacing the second column with that. And we get 2 times 7 minus negative 5 times 3, which is 14, plus 15 equals 29. Now, D sub X divided by D, 58 divided by negative 29 is negative 2. D sub Y divided by D, 29 over negative 29 is negative 1. And as you can see, we have the same pair as expected. So it's pretty straightforward, everybody. Determinant of a 3 by 3 matrix. You decide to expand it with respect to one of the rows or columns, makes no difference. Okay. So if you decide to expand it with respect to this row, you get A11 times this. And then they alternate with the sign, or as I mentioned in our lecture, it's -1. The coefficient here, everybody, is negative 1 to the power of I plus j. So A11, for example, would be minus 1 to the power of 1 plus 1, which makes it positive 1. But if you're looking at, so you know why they alternate. If you look at this guy, it's negative 1 to the power of 1 plus 2, which is negative 1 to the power of 3, which is negative 1. That's why they alternate in any event. So you get rid of this, okay? So for this one, you get rid of this, you have those. Minus A12, you get rid of this, you have A21, A23, and the rest of them, and so on. So this is how you do the determinant. So I'm gonna erase my work. And so the 2 by 2 determinants are called minors of the 3 by 3 determinant. We choose to expand across something, for example, row 1. And if you do that, for example, this one would become 5 times the determinant of this, okay? Then I'm going to erase and show the next one. Minus negative 8, because it's going to alternate. And now the determinant of what is left, 3, 4, minus 5, 1. And the last one was this one, and it's plus 6 times what you see left. Okay. So I think it's pretty straightforward, everybody. So this one is 0, 0 times 1, 0, minus negative 8. Then we have a plus 8, 3, minus negative 20. This one plus 6 times, minus 6 times, minus 0. That's what you have here. So this is positive 8, this is plus 8, this is 23, this is 6 times negative 6, and they end up being 188. If you put that into technology and call this matrix P, it's a 3 by 3, and put in the elements, the entries, and determinant of B will be 188. The other method is to put 2 of them next to each other, everybody, and follow this, go this rows, okay, this way diagonal positive, this way diagonal negative. So we're going to go with those, which is 5 times 0 times 1, plus negative 8 times 4 times negative 5, plus 6 times 3 times minus 2. And then minus, okay, now we put in brackets or parentheses those, minus 5 times 0 times 6, plus negative 2 times 4 times 5, plus 1 times 3 times minus 8. And as I mentioned, you calculate this, you subtract this. That's why we have this negative sign here from this one, and 124 minus 64 gives you the same answer. When you want to do it by hand, perhaps this is the fastest way, okay? So of the system, 3x minus 4y plus 2z equals negative 15, 2x plus 4y equals plus z is 16, 2x plus 3y plus 5z equals 20. And we are going to solve it quickly, try to solve it quickly by hand and also technology. So we're going to call them equations 1, 2, 3. So we can refer back and forth. Notice, first of all, you decide what variable to get rid of, and pretty much any of them will do. But since these two are opposites, quickly, if I put equations 1 and 2 together, if I combine these two, right away these two cancel each other, and I get 5x plus 3z equals 1. I don't have to do anything. I'm going to just mention equation 1 plus equation 2, and I'm going to call that equation number 4. So because I'm going to need that, so I'm going to call this equation number 4. Now, it's important to know the equation that hasn't been used, that means this equation must be used. Whether you use the first or the second one now, it makes no difference. And you must get rid of the same variable, namely y. Okay? So how do we do that? Let me erase my word. So we are using this. And since this has a negative sign, let's use the first one multiplied by 3, this one multiplied by 4. You multiply this one by 3, you get 9x minus 12y plus 6z equals negative 45. This one will give us 8x, 12y, 20z, 80, and clearly these two cancel each other. 17x, 26z, positive 35. And now we call this equation number 5 since we are going to need this, okay? So we can go back and forth. We know which one we are referring to. Now, so we have two different equations now that they have two variables. So we're going to put 4 and 5 next to each other. And now a system of a 2 by 2 in essence. And we decide to get rid of one of the variables. It makes no difference which one. For example, if you want to get rid of the x, you multiply this one by 17, this one by 5, one of them negative. You want to get rid of the z, this one by 26, this one by 3, one of negative. So let's multiply this one by 17. We get 85x plus 51z plus equals 17. Let's multiply this one by negative 5. We get minus 85x plus 26z plus 35 becomes minus 85x minus 130z minus 175. So these two cancel each other. These two add up to negative 79z. These two add up to 158. Divide by negative 79. And you get positive 2. So we got the z. And as long as we use one of these two equations, for example, equation 4, we can find x. So 5 times x plus 3 times 2 equals 1. This is minus 5 divided by 5x becomes negative 1. So again, pretty straightforward, everybody. You go back to one of the original equations, for example, equation 1, and you put everything in. What's missing is y. So we get 1 here. divide by negative 4, y becomes 4. So we got the answer. I'm going to again erase my work. And you have to check. I'm going to leave it for you to check. Remember, we used equation 1. So you have to check with equation 1. You have to check with equation 2 as well as equation 3. 2 times negative 1 is minus 2. 4 times 4 is 16. And z is 2. They cancel each other, 16. So the second one works. Check the third. We also can look at it from the point of view of the matrices. So what we can do is to use the augmented matrix. So as you can see, it's very simple. You can go with the row or column 3, 2, 2, negative 4, 4, 3, 2, 1, 5. And by the way, if any of them is missing, you have to have a 0 there. Minus 15, 16, 20. And you put that into technology. So you have a dimension first. You choose one of the matrices A, B, C, and you change the dimension to 3 by 4, and you enter all those entries. So that's your matrix. There wasn't enough space to show all 4 columns. That's why I went to the next one. And you can do REF, and you can change it, of course, to a fraction if you want. This is REF. But if you do REF, then this will be the solution, everybody. Or REF, that would be the solution. Very straightforward. Again, I hope everybody's fine with that. It will speed up the process. All right. Let's look at this. X plus y plus z equals 14. 2y plus 3z is negative 14. Negative 16y minus 24z is negative 112. And we see that this one has all 3 variables. This has y and z. This has y and z also. So let's do these 2. Let's combine them in a manner to get rid of one of the variables. So let's say we want to get rid of the y. Let's multiply this by 8. If I multiply this by 8, I get 16y plus 24z. 8 times negative 114 is negative 112. And when I add them up, these 2 cancel each other. These 2 cancel each other. I get 0 on the left, but these 2, they don't cancel each other. I get negative 224. It doesn't matter what I get, as long as it's a false statement. There's no solution because the system is an inconsistent system. So with no solutions, okay? All right, we want to solve this one. If we want to get rid of the x, let's multiply this one by 3. And this gives us negative 3x, negative 9y equals negative 6. The second one doesn't change. They add up to 0. They add up to 0. Everything adds up to 0 both sides, which is a true statement, which is an identity. So it makes it a dependent system with infinitely many solutions. If we were to use an augmented matrix and technology, the augmented matrix would be -1, 3, -3, 9, -2, 6. And if we put REF, that gives us a row of all zeros. A row of all zeros indicates 0 equals 0, indicates a dependent system which has infinitely many solutions. We want to solve this system, and this is a system of inequalities. Notice these two, if you just add them up and don't do anything, they cancel each other. So let's add them up. They cancel each other. This is 4x squared. So, and this is 28. That means x squared is 7. And that means x is plus minus squared of 7. Now use one of the equations to find the y. And of course, the second equation is easier. Because x is being squared, positive and negative makes no difference. Let's put both of them in there. This results in 7. So y squared is 9, and y is plus minus 3. Please understand, this corresponds to the following 4 answers. And you have to check really with only the first equation because we use the second equation to come up with the answer. So I'm going to check one of them. Okay. If we check the first one, that means 3 times x minus square root of 7 quantity squared minus y, that means -3 squared. And we want to see whether we get 12 or not. This is 7, so 3 times 7 minus this is 9. 21 minus 9 is 12. It checks. You should check, class, and I can't emphasize this enough. Craft a system of inequalities. First, you change them to equalities. Then you pick up a couple of pairs. Both of them are lines. All you need is a couple of intercepts. If x is 0, y becomes -2. If y is 0, x becomes 1. In this case, x is 0, y becomes 3. Y is 0, x becomes 2. So it's easy to find the intercepts. I'm going to assume we have no problem finding the intercepts. This one doesn't have an equality. This one has. This one is a dashed line. This one is a solid line. So this is 2x minus y equals 2. This is 3x plus 2y equals 6. And we make this into a dashed line. There are 1, 2, 3, 4 regions. We are going to pick a test point, for example, 0, 0, and try it. So for the first one, we put it into this. Here's the test point 0, 0. If I put it into this, 0 is less than 2. Is that a true or false statement? It's true. So 0 is a solution. Everything on this side is a solution, everybody. On the other hand, for the second one, that's a false statement. So in that case, the other side is 3x plus 2y equals 6 is here. This is false, so this side is the solution. And when you put them together, gives you the little top portion. Graph the inequality y is larger than x squared plus 1. First, we graph the equality. As you know, it's a parabola that shifts up by 1 unit. Okay. And all you have to do, pick up a paired test point. You can pick 0, 0, or you can put any other point that is not on. By the way, this is dashed, okay? The reason the parabola is dashed because we don't have the equality. So pick any point. For example, if you pick 0, 2, which means this point, if it works, everything inside the parabola works. If it doesn't, everything outside works. So if I plug in 0, 2 into this one, meaning replace the x with 0 and y with 2, 2 is larger than 0 plus 1, it's a true statement. Therefore, this works. Everything inside works. Just for the sake of argument, if you try 0, 0, 0 is larger than 0 squared plus 1, 0 is larger than 1 is a false statement, and therefore it gives you the same result in case. You get some applications. A chemistry lab assistant wants to prepare 10 liters of 48% acid solution. In stock, it has 80% and 40% acid solution. How many liters of each in stock solution should he mix to get 10-liter mixture? Well, this is a class of problem known as a mixture problem, everybody. We are going to come up with a table such as this one. Now, the concept of a mixture is that when you mix them up, the total volume stays constant. It doesn't change. So we have 80% solution, 40% solution, and a mixture. And what happens is that you can leave it as that, or just 0.8, leave it like that, or 0.4. The mixture is 48%, or 0.48. The volume, we know we have 10 liters of 48%. And we don't know how much of each. So let's say X and Y. You got to, define your variables. And the pure amount of acid, the actual amount is the product of these two. So we have, for this one, we have 0.8 times X. For this one, we have 0.4 times Y. And for this one is 0.48 times 10. That's how you set them up. And this is one equation, x plus y equals 10, and this is the second one. You can do it by any method. You can do it by substitution. For example, here, if you solve for y, or you can multiply by, for example, 0.4 negative and get rid of the 1. So now we are going to replace it here. 0.48 times 10 is 4.8. We should know that. So this remains. This is 4. This is negative 0.4x. These two combine into 0.4x, and the right side is 0.8 divided by 0.4, x becomes 2. So if x is 2, y must be 8. So we have 2 liters of 80% solution and 8 liters of 40% solution. We continue with mixture problems. How many liters of a solution that contains 15% chemicals must be mixed with 6 liters of solution containing 10% chemicals to make a solution containing 12% chemicals, and you need the same type of table. And again, you can keep them in percentage, or you say this is 0.15, 0.1. What is the mixture? 12%. So 0.12. And by the way, we have 6 liters containing the 10%, 0.12. So how much of the 15%? I have no idea. How about X? And here's the beauty of the mixture problem. The volume can't be changed. It's constant. So they must add up to give us the resulting mixture. And so we have that one. And then the product of these two is the pure amount of chemical, the same here, the same here. So 0.15x, 0.1 times 6, 0.12 times x plus 6. They add up. 0.15 times x plus 0.1 times 6 is 0.12 times x plus 6. And we are going to distribute, and we get, oh, this one doesn't change. This is just 0.6. This one is 0.12x, and this is 0.72. Moving things around as follows. We get 0.03x equals 0.12. X is 4. So we need 4 liters of 15% solution. A plane can travel 800 miles per hour with the wind and 720 miles per hour against. Find the speed of the wind and the speed of the plane in still air. Set up a system of equations. We can go, first you have to define your variables. We can go with x and y, but I'm going to go with the initials here, plane. The speed is p miles per hour, wind is w. When you go in the same direction as the wind or the current, the speed of the wind and the current will help you, will be added up to yours. If you're going against those, they work against you. So this one, we are going with the wind. So P plus W is 800. This one is against it. P minus W is 720. And now, if you add them up, these two cancel each other. This becomes 2P. This becomes 1520. Divide by 2, you get 760. And if P is 760, with what number becomes 840? You, in fact, check it with both equations. So the plane is doing 760 miles per hour. The wind is at 40 miles per hour. Admission tickets to Braden River Little League All-Star Game cost $4 for adults, $1.50 for children. A total of 225 tickets were sold, and a total of $500 was collected. how many adult tickets and how many children tickets were sold. We're going to set up a table so we can set up a system of equations. So here's adults, children, and the total. So the ticket cost for adults is $4, $1.50 for the children. We have a total of 225 tickets, so the number is 225 here, and the total amount collected is 500 here. So again, I'm going to go with the initial instead of X and Y. I'm going to go with A and C. A represents the number of adults and C represents the number of children. So it's easy to see that when you go that route, it's very easy to understand the process. And so how much do we collect from the adults? 4 times A. And from the children, 1.5 times C. So these two must add up, these two must add up, resulting in the following set. A plus C must be 225, 4A plus 1.5 C must be 500. Let's get rid of one of the variables. For example, if we want to get rid of the A, we can multiply this one by negative 4. If we want to get rid of the C, we can multiply by negative 1.5. Let's multiply by negative 4. We get minus 4A minus 4C minus 900. These two cancel each other. These two add up to negative 2.5C. These two add up to negative 400. Okay. And 100 divided by 25 is 4. 4 times 40 is 60. 160. And so if C is 160, A must be 65 because they must add up to 25. So it's easy to use this one to get to A, and you must check with the second equation. All right, question number 12. One leg of a right triangle is 4 centimeters less than the other one. The area is 70 square centimeters. Determine the length of each leg. Well, here's X, here's Y, the two legs. The area is 1/2 a base times the height. So X seems to be smaller. So X is Y minus 4. One is 4 centimeters less. Area is 1/2 base times the height, 1/2 X times Y. When you have a right triangle, the legs are, one of them is a base, one of them is the height. So that's equal to 70. So first and foremost, let's get rid of this 1/2. Let's multiply by 2, and that brings XY equals 140. Then let's do the substitution. Replace the X here with Y minus 4. It's given in that format. So we have Y squared minus 4Y equals 140. Y squared minus 4Y, and move the 140. And now you want two numbers. The product is negative 140. The sum is negative 4, negative 14, and positive 10. So Y is either 14 or negative 10. Dimensions can't be negative. This one is out. So if y is 14, x must be 10. Does this make sense? You have to check with this. If you multiply the two, 140 times 1/2, you do get 70. So it checks. So it's an easy check. The sum of three numbers is 105. The third is 11 less than 10 times the second, twice. The first is 7 more than 3 times the second. Find the numbers. First, let's give them names. Let the numbers be x, y, z. So the first one is x, or anything you want, but define it. The second one is y, the third one is z. So we go one by one. This one says the sum is 105, x plus y plus z must be 105. So that's the first. Then it says the third z, the third z is 11 less than 10 times the second. That means 10y minus 11 because the second one is y. Twice the first, 2x, is equal to 7 more, 7 plus 3 times the second, 7 plus 3y. So that's x plus y plus z equals 105. The third one we called it z is 11 less than 10 times the second, so 10y minus 11. Finally, twice the first, 2x, is 7 more, 7 plus 3 times the second, 3 times the second, which is y. So that was first understanding the concept. Now equation 1 has 3 variables. This one is solved for z, and I can replace the z here, and it becomes a function of 2 variables. This is a function of 2 variables. Then I can combine them with the last one to get something out of it. So first and foremost, let me replace the z here. And again, equations 1, 2, 3. It's a good idea to call them equation so and so. So plus 10 times, so we have, instead of z, 10y minus 11. So we have x, let's do this. 11y here. Move this. So we get x plus 11y equals 116. So equation 3 and equation 4 will be put together. One easy way and somewhat different is this. You notice 2x, everybody, is 7 plus 3y. This is not 2x. If it were 2x, I could replace it. I'm going to multiply this one by 2. And I get 2x plus 22y is 232. Now I can replace the 2x with this. Slightly a different method, but a pretty fast methodology. Okay, so this is what we did, okay? Now these two add up to 25y. Subtract the 7 and you get 225. Divide by 25 and we get 9. And now we can go to equation 2 to find the z. Z is 10 times y. That means 10 times 9. That means 90. Minus 11 and we get 79. And we can go to The first equation, they all add up to 105. So y is 9, z is 79, 88, they add up to 88, subtracted from 105, x becomes 17. Those are the three answers. And I hope you recognize, basically, you've checked everything. You want to check it with the last one as well. 2 times x is 34, 7 plus 3 times 9, 27 is also 34. We are done here, but just for the sake of argument, if you write the augmented matrix would be 1, negative 10, 2. I'm sorry, 1, 0, 2. This is y. So 1, 0, 2, 1, negative 10, negative 3, 1, 1, I don't see z 0, and then 105 minus 11, 7. So this is the augmented matrix, everybody. Put it into a calculator, and if you do RREF, you can see the last column as the answer. So that's pretty straightforward, everybody. We are going to move on. All right. Now let's switch gears to partial fractions. We know how to add rational functions. The reverse process is called partial fraction decomposition. Partial fraction decomposition is used when we have a fraction of the form p of x over q of x, where p and q are polynomials and the degree of p is less than the degree of q. That means it's a proper form of a fraction. If it's equal, you have to do a long division, or if it's larger than, if the degree, okay? Note, if the degree of the numerator is larger than the denominator, then perform long division. Even if it's equal, you have to do that. We have different cases. If we have distinct linear factors, such as this one, we put a over x minus 2, b over x minus 1 to come up with the answer here. If we have some repeated ones, like x minus 1 quantity squared, we have to put a over x minus 1, b over x minus 1 squared, c over x minus 2, and do the job. If we have irreducible quadratic factors, we put a over x minus 1, and this one, because it's degree 2, the numerator becomes degree 1, bx plus c, and you handle it. And if it repeats, you have to do just like this one, another one to take care of the business. So that's the concept of a decomposition. Let's look at an example. So here's the first case where the denominator is a product of distinct linear factors. We are going to factor this. First, we take the denominator, we take the x out. I'm assuming nobody has any problem with the factoring. We get 2x minus 1 and x plus 2. And now this is equal to a over x plus b over 2x minus 1 plus c over x plus 2. we are going to multiply both sides by the denominator, x times 2x minus 1 times x plus 2. When we multiply by the denominator, or LCD, the left side simply becomes the numerator. What happens here, it's a times 2x minus 1 times x plus 2. This is b times x plus 2, and then c times x times 2x minus 1. Now, there are two ways to do that, and I'll go over this method. First, you have to go with like terms, and their coefficient must be the same. This one is the product of these two is 2x squared minus x 4x plus 3x minus 2. This one, the product is x squared plus 2x. This one is 2x squared minus x. So you write those. And now you collect like terms. Just for the sake of argument, if you look at x squared, and I want you to pay attention to this one, we have x squared times 2a plus b plus 2c. For x, we have x times 3a, this one, plus x times 2b, and x times c, so we get 3a plus 2b minus c times x. And finally, the numbers, there is this constant of a times negative 2, or minus 2a. And now, the coefficient of x squared is 1, so this must be 1. 2a plus b plus 2c must be 1. The coefficient of x is 2, so 3a plus 2b minus c must be 2. And negative 1 is the constant, minus 2a must be negative 1. So this results in a being negative, a being positive 1/2. Divide by negative 2, everybody. And then plug it back into this to get rid of the a and this one, and then solve that. I'm going to leave it for you to solve it. B becomes 1/5, C becomes negative 1/10, and here's the answer. I'm going to quickly discuss the second method and remind you of the second method, which actually is a fairly easy one to handle this. So the way it works, the second method, everybody, you look at this one and you say, if I choose x equals 1/2, this becomes 0, this becomes 0, I find b. If I choose x equals negative 2, this goes away, I get the c. You see that? If I choose x to be 0, this goes away, and I get a. So just for the sake of argument, if we choose x to be 0, let's see, then the left side is negative 1, right? This is negative 1. And the right side, this goes away, we are looking at this one, which is a times minus 1 times 2. And as you can see, this will result in a being 1/2. So there's a very fast way of handling it in this manner. We want to use partial fraction to decompose. We factor the x out, we get x times x squared plus 4. And so this is the case where q of x contains irreducible quadratic factor, none of which is repeated. So it has x squared plus 4. So this is a over x and then bx plus c over x squared plus 4. Because this is degree 2, the numerator must be degree 1. If you multiply both sides by LCD, namely x times x squared plus 4, then this goes away. You get the numerator. This becomes a times x squared plus 4, and this becomes bx plus c times x. So the left side has x squared as x has a constant. The right side, the same thing. So starting with x squared, I hope you recognize this x squared times a plus b, because this, everybody, is b x squared plus cx. So therefore, we have x squared times a plus b. Then we have cx, then we have 4a. So now actually it's very simple. A plus b must be 2, c must be -1, 4a must be 4. So there's really not much to it. It's actually easier to go this route. And 4a is 4, so a is 1, c is -1, right? C is given, a becomes 1. Plug it in here. If a is 1, with what number becomes 2, b becomes 1. And now put it into this. And you get 1 over x plus x minus 1 over x squared plus 4. It's actually a lot simpler using this methodology.